ओके चलो लास्ट क्लास का कंटिन्यूशन करने वाला है. Obtain the expression for the induced EMF and induced current at any time t when the coil is rotating under magnetic field. Okay, so at any time, suppose magnetic field is like this. This is a coil. It's rotating with angular velocity omega. ऐसा घूमता जा रहा है, zoom 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 zoom. उसका वजह से area will change definitely. Before magnetic field length smaller 10, when it rotated like this, it may be 1. So it got changed. Therefore, there is a current is also induced, EMF also induced. Okay. Now he's asking expression for induced EMF and induced current at any time t when the coil. Okay. Find karo. Cos theta. Can you tell me theta is the angle between, initially I told you area vector and magnetic field both are in the same direction. So angle is 0. First always आपको initially 0 लेने का. So flux is BA. Now मान लो आपको ठीक है ईएमएफ कितना हो, ईएमएफ फाइंड करो बाय यूजिंग फैराडेज लॉस. ओके ठीक है, इसमें हम लोग क्या करेंगे, इज एंगल तो 0 है. मान लो कॉइल इज रोटेटेड लाइक दिस एट एन एंगल थीटा. ओके देन व्हाट इज द एंगल बिटवीन एरिया वेक्टर एंड द मैग्नेटिक फील्ड इज हाउ मच, एरिया वेक्टर एंड मैग्नेटिक फील्ड. द कॉइल इज इनिशियल ऐसा था बिफोर. ओके 0 था तो रोटेट किया, area vector got changed like this, magnetic field to inside only, angle between them is theta. So that time flux will be how much, BA cos theta ले लो. We are taking BA cos theta. Cos theta. BA cos theta is a formula for flux. Now tell me what is the EMF induced formula. EMF फाइंड करने का, करंट फाइंड करने का when rotating at a certain time t. मान लो certain time t में रोटेट किया. Okay, now what in terms of omega I want, what is omega is equal to theta by t. Theta is equal to omega t, right? Substitute in terms of omega में, flux B is equal to B A cos omega t. Now flux आ गया, find EMF, E average और incidence find करो. So E incidence will be how much formula, mod d phi by dt. और डिफरेंशिएट करने का इसका mod d by dt of flux is BA cos omega t. Okay, so either B constant, area vector is constant, area is same, right? And cos को डिफरेंशिएट करने का, right? So क्या आएगा, BA cos का डिफरेंशिएशन नथिंग बट माइनस साइन ओमेगा टी. ओके इनटू द चेन रूल यूज करने का, ओमेगा टी का डिफरेंशिएशन ओमेगा मॉड है ना. So therefore EMF induced is equal to B omega A sin omega t, right? This is the formula. Okay, now if this is for one coil, suppose if they मान लो if there are n coils, आपको n लगाना पड़ेगा, n BA omega t omega, right? चलो now I want to find EMF maximum EMF. ठीक है, if n turns are there, use EMF will be how much, n BA omega sin omega t. Okay, मान लो n turns are there, n the general expression we are calculating. What is the EMF maximum EMF? Tell me, maximum EMF will be how much? Sin value is how much? 1, right? So NBA omega. I call this as E naught. NBA omega. This is the maximum voltage induced in the coil. Okay, and this E is called as instantaneous EMF. Instantaneous EMF. Instantaneous EMF is a formula. And current चाहिए बोलते हो I is equal to E by R. Just करेंगे. Okay, तो मेरा so आपको it can be circular coil, it can be rectangular coil, any coil होने दो. When I rotate certain angle theta, the EMF will be used the same, NBA omega sin omega t. And maximum voltage if they ask, simply use the formula. Again, no need of procedure. This is even generator also same formula. AC generator पढ़ने वाला है लास्ट में. AC generator में वही है, rectangular coil में मैं घुमा रहा हूँ. घुमाए तो same voltage आएगा, same expression आएगा. And this is the introduction for AC also. AC में starting this only we are taking. घर का voltage is sine wave form, sine voltage. That's why sine terms में आ रहा है. So this is called instantaneous EMF or voltage, and maximum voltage is NBA omega. Okay, अब चलो now directly use करेंगे. अभी दूसरा क्वेश्चन है तो directly use करेंगे. देखो करो. A circular coil of area is given, number of turns is given, a vertical diameter is rotating with angular speed of this much घूम रहे हैं. Okay, in a uniform horizontal magnetic field is horizontal है. And Tesla is given. Find the expression of maximum voltage I want. That's it. I want directly maximum voltage. E not find करो. वो कैसे भी रहने दो. E not का formula use करो. What is the formula of E not? NBA omega use करो.
(1.5)
Yes, 1.5. volts. Everything is given, Sriram. Area 300 into 10 power of minus 2 whole square. Okay, so 25 into magnetic field they given as 0.05. Area they given as 300 into 10 power of minus 4 into omega is 40. So substitute किया तो you get as 1.5 volts is answer. This is the maximum EMF you use. Find करो. Next. That use the result. That's it. A rectangular coil as a dimensions this much. Length into breadth is given. The coil has this much turns, and the coil rotates in the magnetic field about the axis parallel to the length of the perpendicular magnetic field. Okay. A field is magnetic field also given. The speed of rotation of the coil also given. 4000 RPM. RPM means
rate per minute, rotations per minute.
Revolutions per minute. So आपको what is this given? Tell me.
Frequency.
What is this given?
Frequency.
Frequency is revolutions per second. आपका frequency convert कर लो always. 4200 by 60. या तो this is the frequency. Okay. Calculate the maximum value of EMF in the coil. आना find करो. कितना? 70 hertz. Okay. Now calculate maximum EMF induced in the coil. So maximum EMF is E naught है ना? So NBA omega. Frequency is given. We know the formula. Omega is equal to 2 pi f. We done in circular motion, right? 2 pi f. Subs करो. All values subs करो. NBA 2 pi f. Del answer.
Uh, 28 pi or 144 approximately.
E naught is how much?
NAB omega.
Oh no, value subs किया. Answer कितना है?
28 pi or 144.
28 pi. No, wrong.
So 336.
336
36.
huh? थोड़ा wrong. So n is how much? 2000 into magnetic field 0.02. Area is how much? This into this, right? 0.2 into 0.1 into 2 into 22/7 into F is 70.
352, sir.
कितना?
352.
352, yes. Approximately 352 volts आएगा. Is the voltage. Now you're asking instantaneous value of EMF. We know instantaneous means at particular angle में कितना EMF is getting induced. That is that formula क्या है instantaneous का EMF is E is equal to E naught sin omega t. खत्म. Now omega t they given us 30 degrees. Omega t they given us 30 degrees. Now find EMF.
One 76
Yes.
volts.
Yes. So 352 into sine that is 1/2. So it is 176 volts is the instantaneous EMF. Matlab at when the coil is rotating at 30 degrees, the EMF induced is nothing but 176 volts. Every angle mein the EMF will change. Oh, kitna means instantaneous value if we use, we can find. At 90 degrees we can find, 60 degrees we can find. These are instantaneous. This is the maximum EMF is this much. Okay. Chalo. Iska bolo. Obtain the expression of induced EMF and induced current at any time t when the coil is rotating at angular velocity like this. ऐसे घूम रहा है. What is the EMF and current is how much? Correct one बोलो. चलेंगे. Try करो.
It says in this is the same thing we just did, right?
We rotated like this right before. ऐसा घूम रहा है. But now the coil is rotating like this. Same axis में rotate हो रहा है.
Oh, okay.
Now EMF is how much? EMF is induced. EMF induced is how much?
Is it just BA by R?
No. सादिक बोलो.
So I got the same thing. I got VA by TR.
भाई BA by कैसा फ्लक्स फाइंड कर रहे हैं. चेंज इन फ्लक्स कितना है? टेल मी नॉर्मली चेंज इन फ्लक्स. Initially magnetic field and area vector is in the same direction. Initial final flux is also magnetic field, area vector the same vector. Angle is how much? दोनों में सब्ट्रैक्ट किया तो BA इसके तो जीरो आएगा. EMF is zero. Okay. See if you see by Faraday's laws, initially मान लो 10 lines are passing. The coil is rotating about this axis only. बाद में also 10 lines only passing. The flux is constant. Whenever there is no change in flux, Faraday ने क्या बोला? There is no EMF, there is no current. So EMF is zero. Current also zero. Okay. चलो. So we are doing motional EMF का we done it. We are doing motional EMF now. New topic is motional EMF का. So we done Faraday's laws का पूरा हो गया. Faraday's laws में कैसा what we done? Normally coil को initially मैं ऐसा rotate किया. बाद में मैं coil rotate करने से we got the EMF induced. Okay. चलो. Now we'll go for a motional EMF. Motional EMF आपको मैं part 1 part 2 में कराऊंगा. Motional EMF किया तो maximum chapter हो जाएगा. उसके बाद inductance, mutual inductance will be there. Okay. So motional EMF क्या है? Name itself indicating motional EMF. Whenever conductor is moving under the magnetic field, the conductor will behave like a battery. उसके पास EMF होगा. Okay, that we'll see. देखो, the EMF induced across the ends of the conductor due to motion in the under the magnetic field is called motional EMF. So EMF induced across the ends of the conductor. Suppose मान लो you have magnetic field inwards. There is a rod of length L. It is moving with velocity V. Okay. So एक rod है, rod is a conductor, magnetic field है, length L is a rod length. All are mutually perpendicular. देखो, length is along the y-axis, velocity is along the x-axis, and z-axis में magnetic field है. Okay, at that time, whenever the rod is moving under the magnetic field, what it told, an EMF induced across the ends of the conductor. So that means simply the rod is behaving like a battery. So the rod is behaving like a battery, and plus minus इसके पास EMF भी हो जाएगा. EMF will be induced across the ends of the conductor. Okay, that EMF का formula है BVL is a formula. BVL. B is a magnetic field, V is the velocity of the rod, and L is the length of the rod. BVL is the formula. And this EMF is called motional EMF. Whenever rod is moving, then only it is called motional EMF. Okay. And this formula is useful only when magnetic field, velocity, and length all are mutually perpendicular to each other. वो लिख लो. BVL are mutually perpendicular to each other. Okay. तो थोड़ा small 2 steps में derive भी करेंगे how we got motional EMF. So understood, motional EMF means whenever rod is under the motion, the EMF will be induced. And direction कैसा आएगा? Which is plus, which is minus? How we got only plus ऊपर नीचे minus plus? So which rule we have to use? Any rule we have to use to find the sign plus and minus? हाँ बोलो, बोलो something. Okay, simply use the right hand palm rule. Palm rule उससे हो जाएगा. देखो palm rule क्या है? Magnetic field is inverse लगा है 4 fingers. Motion of the conductor, velocity is direction is right side, right? So आपको thumb indicate the direction of the velocity, and the palm indicates the direction of the positive direction. Okay, the palm represents the positive direction. That's why I put positive. This is negative. And positive से only always current will be coming. Positive terminal से only the current is coming. If it is a closed circuit, current will flow. Okay. So BVL is nothing but motional EMF. So we'll derive the expression also by using the Faraday's law. Se we'll derive the expression. Okay. So मान लो you have a L-shaped frame is here. Okay. It is under the magnetic field. Okay, L-shaped frame is here. Okay. Here I am putting one rod. Sliding rod. I can slide from the wire. Okay. इसका लेंथ है L. रॉड का लेंथ है L. And the rod is moving with some velocity V in this direction. Magnetic field तो inverse है. So definitely मुझे मालूम है EMF का BVL. All are mutually perpendicular to each other. That's why BVL. Now we'll derive. So मान लो in time dt, small time interval में, okay, the conductor moves. The conductor moves through a distance dx. मान लो in dt time interval में the conductor got moved through a distance dx. इतना distance travel किया. ये sliding है ना, ये wire slide हो रहा है. Okay. Now देखो area is changing or not? Tell me, area is changing. Before the area is this much. When the rod came up to here, the area was increasing. Change in area will be how much? Change in area, tell me. dA will be how much? कितना होगा बोलो?
dx into L.
Simply this only, this is the changing area. So dx into L, L into dx. Okay. Now our intention is to find what? EMF by using Faraday's laws. EMF kitna induce hoga. Whenever there is a change in area, definitely the EMF will be induced according to Faraday's laws. Okay. So we use the flux formula. Flux kitna hoga initially? B A cos 0, because magnetic field and area vector is in the same direction. That's why cos 0 lagaya. Magnetic flux is BA. Now EMF induced formula will be mod d phi by dt. So I'm substituting d by dt of flux is BA. Okay, B is constant, bahar aa jayega. dA by dt. And you know what is dA? dA is nothing but L into dx. So B into L into dx by dt. What is rate of change of displacement? Rate of change of displacement is called velocity. So therefore, EMF, motion EMF small e से represent करेंगे. BVL is a formula for motion EMF. BVL. Okay. Faraday's law से application, because questions also a moving frame से भी देगा, मतलब ये sliding वाला wire questions देगा, so that you will understand. So when we have to use this formula, whenever rod is okay, when we are use all mutually perpendicular to each other. Okay, length, magnetic field, velocity. Understood, Sridham? EMF is BVL is a formula. I'll send the formula sheet also with you. And battery कैसा आएगा? Magnetic field is like this, velocity is like this. The palm represents the positive direction. That means this is acting like a battery of EMF E plus minus E. बैटरी से रिप्लेस कर सकते हैं, मतलब रॉड को बैटरी जैसे एक्ट होगा सिंपली मोशन के वजह से, राइट? चलो, यू नो ऑलरेडी राइट हैंड पाम रूल यू हैव टू यूज. कौन सा है? फिंगर्स फील्ड है, थंब मोशन, पाम इज पॉजिटिव टर्मिनल. दिस इज अ राइट हैंड पाम रूल. सो फिंगर्स कौन सा है? फील्ड है, थंब वाला मोशन ऑफ द कनेक्टर, एंड द पाम रिप्रेजेंट्स द पॉजिटिव टर्मिनल. दिस इज बैटरी डायरेक्शन पॉइंट करने के लिए. ओके, चलो.
So could you go to the previous slide for a second?
Yeah. Next. So field, motion of the conductor and position. Okay, chalo. Now questions करो. Find the current in 5 ohm resistor. 5 ohm resistor है. The length of the wire is 25 centimeters and moving with velocity 5 meters per second. And magnetic field is also given 0.4 Tesla. Is asking current. Current के लिए, when the rod is moving, it is having EMF, right? EMF find करो. And current का formula is E by R, right? No, find करो. Here all are mutually perpendicular to each other, right? Length is along the y-axis, velocity is in along x direction, and magnetic field is along z-axis. All mutually perpendicular to each other. Find E. Small e से represent करें. Motional EMF कभी भी small e से represent. There will be options like this.
0.1.
Yes.
No, इसका बोलो. Here R is there, here S is there.
R is the positive terminal, so R to S.
Yes, correct. This is answer. So ये तो आ गया ना, EMF का formula is BVL by R. If you solve, you'll get the 0.1 ampere. But now देखो, magnetic field is inverse. The motion will be in the right side, and the palm represents the positive terminal. So this is a positive terminal, this is a negative terminal. So positive terminal say only current will be flowing. So current is flowing like this, and R to S only the current is flowing. R to S. That's why R to S is answer. So that means आपको direction also important है. Sometimes options में they'll give. So this formula will be useful only when all three are mutually perpendicular to each other. When they are not perpendicular, then कैसे आएगा? Which formula? Anybody आता है formula?
You take cos components.
हाँ, cos component बोलो, full form क्या है? करने हैं? Okay, चलो देखो. When motional EMF, when B, V, L are not mutually perpendicular to each other. So that at that time simply use the formula. इसमें थोड़ा first year का भी use होगा. Okay, is V cross B dot L. This is the formula for motional EMF when all are not mutually perpendicular to each other. And it's general formula. This formula, even though we mutually perpendicular also we can use. We'll get the same result only. BVL only आएगा. Okay. So when they are not perpendicular, V cross B dot L. So आपको learn करना पड़ेगा इसका क्या क्या कहानी है बोल के. Okay. Cross product का कहानी मालूम है ना? L is called here displacement length. याद रखो आगे आएगा. Displacement length. Okay. And A cross B का formula याद है? A cross B first year का mod A mod B
Sin theta.
sin theta and n cap direction, very important. This direction is important. You tell me, yes, sin theta is the angle between what? Sin theta is the angle between here when you expand VB sin theta, right? Theta is the angle between velocity and magnetic field, right? Velocity magnetic field. Okay. This dot product किसका बीच में angle है? This dot product angle किसका बीच में? V cross B का direction and length का. That is important thing. आपको here n cap is important here. वो A क्रॉस B का कौन सा डायरेक्शन है? सपोज A क्रॉस B का डायरेक्शन ऐसा है, लेंथ ऐसा है, सो एट द टाइम उन दोनों का एंगल डिफाइन करना पड़ेगा. सो V क्रॉस B का डायरेक्शन इज इंपॉर्टेंट. ओके, सी नॉर्मली V sin थीटा तो आ जाएगा, बट डायरेक्शन V क्रॉस B का डायरेक्शन यूज करके सॉल्व करना पड़ेगा. एंड V क्रॉस B कैसे फाइंड करेगा याद है? लाइक A क्रॉस B वेक्टर्स में वी लर्न राइट हैंड पाम रूल. सपोज A इज देयर, नीचे B इज देयर, ये ऐसे लगाएगा, A से B क्रॉस करेंगे, द थंब इंडिकेट डायरेक्शन ऑफ द A क्रॉस B डायरेक्शन. ओके, चलो नो एक थोड़ा समझ में आएगा क्वेश्चंस के थ्रू. फाइंड द मैग्नीट्यूड एंड डायरेक्शन ऑफ द EMF इन द फॉलोइंग केसेस. ओके, चलो आई एम गिविंग यू ट्राई टू फाइंड द मोशनल EMF. सो दिस इज अ कंडक्टर ऑफ लेंथ L. We'll use the formula and solve. Magnetic field है and it is going with velocity V, right? Whether BVL होगा इधर, BVL नहीं होगा ना, because देखो velocity magnetic field are not mutually perpendicular to each other, right? BVL नहीं है, but it is moving. Motional EMF तो रहेगा. Okay, magnetic field तो है ना. So what is the formula that you use? Since they are not mutually perpendicular to each other, so E is equal to V cross B dot L. Okay, now tell me what is V and B का angle is? V and B का angle is 0. So when you expand VB sin 0 dot L, sin 0 0 0 आ जाएगा. EMF is 0. Okay. Now इसमें से एक कंक्लूजन आएगा, लर्न कर. So suppose this is a magnetic field. Now rod is moving in this direction, V L. Now find the EMF induced, motional EMF. Like how to find it? So since they are not mutually perpendicular to each other, E is equal to V cross B dot L.
0.
Right? Okay, we'll see. V and B का angle is how much? Velocity and magnetic field. Sin 90 zero नहीं ना? So VB sin 90 dot L. Okay, that is VB dot L. Now देखो आपको important thing I told you. ए डॉट प्रोडक्ट किसका है, किसके बीच में? V क्रॉस B एंड L का बीच में. ओके, नाउ V क्रॉस B का डायरेक्शन देखो. V 4 फिंगर्स लगाया, से B के तरफ घुमाओ. V क्रॉस B, थंब इंडिकेट द डायरेक्शन ऑफ द V क्रॉस B का डायरेक्शन. ओके, नाउ V क्रॉस B का डायरेक्शन क्या था? इनवर्स है ना. एंड लेंथ इज लाइक दिस along the y axis, right? Tell me now, angle between them is, angle between them is
90.
90. So cos 90, VBL cos 90, it is 0. समझ रहा है? ये करके करने का देन. ओके, ट्राई करो. ये फर्स्ट ईयर का है श्रीराम, फर्स्ट ईयर का. V क्रॉस B का डायरेक्शन, V से B घुमाओ, उनका डायरेक्शन फाइनली कितना किस तरफ आया? नेगेटिव. दिस इज द V क्रॉस B का डायरेक्शन इनवर्स आया. एंड लेंथ तो y एक्सिस में है, V क्रॉस B तो z एक्सिस में है. सो एंगल बिटवीन देम इज 90. दैट्स व्हेन यू एक्सपेंड cos 90 होगा. ओके, नो ट्राई. सो मैग्नेटिक फील्ड है, रॉड है, ऑफ लेंथ L है, गोइंग विद वेलोसिटी V. ओके, नो फाइंड मोस्टली में.
0.
सभी में जीरो आ रहे बोल के जीरो बोल रहे हैं, नहीं ना. देखो, करेक्ट आंसर इज राइट. सो EMF इज V क्रॉस B dot L. Okay, now V and B का angle is 90. Okay, so VB sin 90 is 1. Okay, okay, dot L. Now first we have to find the dot product आने के लिए आपको V क्रॉस B का डायरेक्शन देखो. V and B मतलब इनवर्स है ना. So V क्रॉस B का डायरेक्शन इज इनवर्स, एंड L का तो ऐसा है. So both angle is 90, cos 90 is 0. So EMF is 0. That means here one conclusion आपको रिमेंबर करना पड़ेगा. Out of these three variables में any two variables are in the same direction, then the EMF is 0. देखो ये दोनों दो वेरिएबल सेम डायरेक्शन 0. देखो लेंथ एंड वेलोसिटी आर इन द सेम डायरेक्शन 0. एंड देखो हियर लेंथ एंड मैग्नेटिक फील्ड आर इन द सेम डायरेक्शन 0. सो वो करने की जरूरत ही नहीं है. सो आपको लिखो, इफ एनी ऑफ द टू, इफ एनी, नोट बोल के लिखो, इफ एनी टू ऑफ L वेक्टर, B वेक्टर एंड B वेक्टर आर parallel, then motional EMF is 0. समझा ना? चलो, मैं एक वन मोर क्वेश्चन दूंगा, आंसर बोलो, देखते हैं. सो मैग्नेटिक फील्ड इज इनवर्स. So the rod of length L is moving with velocity V. I want motional EMF. Find करो V cross B dot L बोल के.
So won't it just be BVL?
देखेंगे, मतलब वही करो, मेथड से करो, V क्रॉस B डॉट L, राइट? Okay, now tell me V and B ka angle is how much? V and B angle is 90. So VB dot L. Okay. Now V cross B का डायरेक्शन क्या होगा? V cross B देखो, V 4 fingers लगो, B. Thumb indicate the direction of the, मतलब upwards is the V cross B and length is also upwards. Okay. So angle between them is 0. Cos 0 is how much? 1. So BVL, which we already know, when they all three are mutually perpendicular to each other, EMF is BVL only. Okay, good, Sriram. Understood? Whenever three are mutually perpendicular to each other, this is a general formula. We can use any questions ko, but luckily if they are mutually perpendicular, directly use BVL हो जाएगा, instead of thinking that all things. Okay. Now देखते हैं who will do. कर. Have you options?
Root 3 by 2 BVL.
Root 3 by 2
BVL.
देखते हैं. सत्य बोलो.
I got the same thing.
Root 3 by 2. ये सेफ जोन है, जो भी बोलेगा तो राइट बोले तो सेफ जोन में रहेगा ना.
Cos
हाँ.
that is green.
So which formula you use, tell me?
V cross B is VB.
Okay, you use general formula, right?
Yes, sir.
V cross B dot L.
Yes.
Okay. Now V and B ka angle is how much?
90.
90, because this is XY plane and Z axis 90. So VB sin it is 1 dot L, right? Now V cross B का डायरेक्शन किस तरफ रहेगा? V cross B. देखो 4 fingers लगाओ, V inside is B. V cross B is like this, right? V cross B. This is the direction of V cross B. And you remember ये वाला? C vector is A cross B means, tell me. Any doubts? C vector is A cross B means C vector is perpendicular to A vector and C vector is perpendicular to B vector. ये याद है वाला? We done the 11th class में. देखो V cross B is perpendicular to B vector, right? एक वेक्टर से कंपस से perpendicular रहेगा ना. The resultant vector is always perpendicular to both L and B, right? Now tell me, what is किसका डॉट प्रोडक्ट, किसका एंगल चाहिए? V क्रॉस B का ना L का. Tell me, V क्रॉस B and L का एंगल इज समझ, दिस एंगल आई वांट. V क्रॉस B का डायरेक्शन वी गॉट, L का वेक्टर का एंगल आए तो कर लो. कितना होगा?
It's a 30.
This is 30, this is 90. This is how much? Total angle is 180, right? 60,
6.
right? Now cos 60 is how much?
1 by 2.
हमारे आंसर कितना होगा?
BVL by 2.
Somebody told root 3L by 2. Okay. चलो समझ आया? So understand, V cross B का डायरेक्शन आपको घुमाना है. V 4 fingers, B is inverse, घुमाओ. V से B and thumb indicate direction of the magnetic field. V cross B का direction, and that is always perpendicular to the velocity or direction. Okay. चलो. Next, I'll give the same type of question. Try one more. Suppose मान लो magnetic field is inverse. Rod है. It is moving with velocity V like this. Angle they given as 45 degrees. Okay, and magnetic field is inverse, right? He's telling to find motional EMF. Length is L. Motional EMF is how much?
BVL by root 2.
Yes, perfect. Answer is right. So EMF is V cross B dot L. So V and B ka angle is how much? V and B ka angle is 90. So VB dot L. So now V cross B का direction find करने का V cross B. So angle के V cross B. This is like this is V cross B, and this is perpendicular to this one. So angle between L and B का L and V cross B का 45 degrees. Total is 90, right? ये 45 तो ये 45 रहेगा. So VB L cos 45 is 1 by root 2. By root 2. Okay, understood? Now any question you can do, right? Okay. Now अभी तक क्या है? स्ट्रेट रॉड के बारे में we learned. स्ट्रेट रॉड के बारे में we learned. अगर कोई डिफरेंट शेप में वगैरह दिया तो भी कैसे करेंगे विल सी. ओके, now देखो सेमी सर्कल शेप, डिफरेंट डिफरेंट शेप का नो. ओके, एंड देखो मैग्नेटिक फील्ड में द सेमी सर्कल रॉड इज मूविंग विद सम वेलोसिटी v, इसका रेडियस इज r. So what is the induced EMF? That means indirectly induced EMF is nothing but motional EMF only. Okay, how to find इसका मेथड बोलो. Whether velocity, magnetic field and length are mutually perpendicular, और V क्रॉस भी लगो, V क्रॉस B डॉट L लगो. सी इसमें क्या करेंगे देखो, आई टोल्ड यू फर्स्ट ओनली E is equal to V cross B dot L. This is a formula we learned, right? General formula you can use anywhere, right? This one. Okay, here what L is what I told. L is what I told. L is called as displacement length. Okay, L is displacement. So always take the displacement length only. Whenever different shape is given, use the displacement length only. So now initial point is here, final point is here. The displacement length is how much? If from here to here is r, from here to here is r, so 2r is there. Okay. Now indirectly this now semicircle का भूल जाओ अभी, displacement लेने के length लेने के बाद semicircle भूल जाओ. Now indirectly the question became like this. Under the magnetic field में एक length of 2r का length है, it is moving with velocity v under the magnetic field. EMF is how much in this rod? Here देखो, length, velocity and magnetic field are mutually perpendicular to each other. Then formula is BVL. L is nothing but 2r. This answer. So always takes the displacement length only. Whenever two or more rods combined or semicircle होने दो or different shapes होने दो, combine करके initial point, final point join करो, that length find करो, then class हो जाए. Okay. चलो, ना करो देखते हैं. Two rods are there. This one rod, this one rod. It is attached with this at point O. Now that complete rod, that L-shaped rod is going with velocity v under the magnetic field. Then इसका EMF induced कितना है? इस rod का EMF is induced कितना है? Okay. And ये पूरा is theta. This will be exactly perpendicular bisector वाला only. So theta by 2, A भी theta by 2. This is given. Now ये different shape है ना, different shape का है ना. So हम लोग क्या कौन सा shape लेने का? Always displacement length लेने का. So initial point and final point को join करो. Initial point is A, final point is B. This is called displacement length L. A length को कैसे find करेगा? Then only we can know that we can find. And they given this length is L. They given this length is L. This length is L. Tell me.
2L sin theta by 2.
Yes. L का इस तरफ component is L cos theta by 2, L sin theta by 2. मतलब this is L sin theta by 2 and this also L sin theta by 2. Total length is 2L sin theta by 2. So you got displacement length. Now indirectly question कैसा हो गया? एक length of rod is there. उसका length is 12 sin theta by 2. And it is moving with velocity v under the magnetic field. So all are mutually perpendicular to each other. That's why motional EMF is BVL. So BVL के जगह में 12 sin theta by 2 is answer. Is it right, motional EMF? Now rail problems. Rail problems I told, right? Rail problems means nothing but the sliding wire जा रहा है ना, एक rail जैसा जा रहा है ना, that is called rail problems only. So rail problems का कैसे करने का we have to know. इसमें आपको learn करना पड़ेगा थोड़ा new type of problems आपको learn करना, थोड़ा बड़ा problems आएगा. देखो that numericals के थ्रू जाएंगे. फर्स्ट एक क्वेश्चन करो, नॉर्मल मेथड से करो and tell the answer. Answer I'll give. Options 0. A conductor A, B, O, C, D moves along the bisector with velocity V. मतलब bisector दिया है, this is 90 degrees. A magnetic field also given. If all four sides are 1 meter length, then the induced EMF between A and D. So since it is a different shape is there, we should take the displacement length. Try to take the displacement length. So this length, right? This length is nothing but displacement length. Or I can take this length only, same only. A length find करो हो जाएगा. पहले L मान लो, this L मान लो, A भी L मान लो. लास्ट में शिफ्ट करेंगे 1 मीटर बोल के.
$1.41.
Yes, correct. देखो 90 डिग्री है ना, इस कॉल हाइपोटेनस. हाइपोटेनस स्क्वायर इज इक्वल टू कितना, अंडर रूट एल स्क्वायर प्लस एल स्क्वायर. सो कितना, रूट 2 एल, राइट. अंडर रूट एल स्क्वायर प्लस एल स्क्वायर 2 एल स्क्वायर बाहर आ जाएगा, रूट 2 एल. नाउ डिस्प्लेसमेंट लेंथ मालूम हो गया ना. नाउ देखो लेंथ इज अलोंग वाई एक्सिस, b is going along x axis, magnetic field is along z axis. That's why all three are mutually perpendicular. So formula क्या है, b v l. So l के जगह में रूट 2l लगाने का. So b is how much the given, 1 into velocity, how much the given, 1 only, and length I told you root 2l, right? Root 2 l is how much, 1 meter. So it is root 2, that is 1.414. So this answer. तो मेरा मोस्टली एमएफ को. चलो नाउ थोड़ा कहानी आपको लर्न करना पड़ेगा. दे कैन कंबाइन विद द मूविंग चार्जेस आल्सो, दे कैन कंबाइन थोड़ा थोड़ा. ओके, मूविंग चार्जेस में एक फॉर्मूला पूछूंगा, बोल सकते हो? एनीबॉडी याद है? मेमोरी फोर को देखते हैं. Whenever current carrying wire is placed under the magnetic field, what is the force acting on the wire? Whenever a current carrying wire is placed under the magnetic field, इसके ऊपर फोर्स लगेगा. राइट हैंड पाम रूल याद है ना. magnetic field is inverts, the thumb indicate direction of current and force is like this. So this is force. Force कितना?
Something cross B.
समथिंग नहीं है, आंसर बोलो कट एक्सेप्ट का. Because they will link now with this.
IL cross B.
Okay, IL cross B. No? थोड़ा रंग एक्सपेंड करके बोलो, ठीक है. What is the formula?
Sin theta.
IBL sin theta. Okay, IBL sin theta, very important. F is equal to IBL sin theta. ओके चलो देखते हैं, आगे क्वेश्चन करो। A conducting rod of length L, लेंथ L है, रॉड है, रेजिस्टेंस R है, it is moving with constant velocity V, ओके जा रहा है। Two parallel connecting rails placed in a uniform and constant magnetic field B to a plane in the rails as shown in figure. A resistance R is connected between the two ends of the rail. Okay, two ends of the rail में I connected one resistance R. Okay. Determine the EMF. EMF find करो, easy right? This is the length of the rod. Rod is moving right under the magnetic field. So EMF is how much? First one. Since length, velocity and magnetic field are mutually perpendicular, BVL. Right? Okay. Now, current find करेंगे. A closed circuit है ना? And definitely you know magnetic field is like this, or velocity like this, and force current positive terminal is like this, right? And negative terminal is like this. It's behaving like a battery EMF, and current will flow. Now current find करो. अब these values are given ना, no right? Directly variables में आएगा. Now current कितना है? And मान लो you write down like this here. This battery of EMF having a resistance R. इधर लिखो internal resistance R. मतलब रॉड का इंटरनल रेजिस्टेंस आल्सो गिवन, इंटरनल रेजिस्टेंस आर, मतलब व्हेन आई कन्वर्टेड इनटू द ईएमएफ इसके पास रेजिस्टेंस स्मॉल रेजिस्टेंस आर होगा। ओके, नाउ टेल मी करंट कितना होगा? करंट इज इक्वल टू ई बाय आर, ई बाय आर इक्विवेलेंट राइट? हियर द सीरीज है ना, दिस इज सीरीज सर्किट राइट? So series में what is the resistance add करेंगे right? R plus R. So what will be the BVL by capital R plus small r. Right आया? So first one done. Now force required to move the rod with a constant velocity. Force required to move the rod with constant velocity. Then कैसे find करेगा second one? B1. I want to move this. First of all, force देखो check करो. Magnetic field is inverse. The velocity is right side. And no, force का फॉर्मूला क्या आएगा? I into L क्रॉस बी राइट? फोर्स का राइट हैंड पाम रूल यूज करके टेल मी फोर्स डायरेक्शन किस तरफ होगा? फोर्स डायरेक्शन किस तरफ होगा? द करंट इज फ्लोइंग लाइक दिस राइट? पॉजिटिव टर्मिनल करंट. नाउ अप्लाई राइट हैंड पाम रूल. मैग्नेटिक फील्ड इज इनवर्स, द करंट इज गोइंग अपवर्ड्स, द फोर्स इज लाइक दिस. देन द रॉड विल become slower or faster? The rod initially is moving like this, but force acting in the backward direction. So धीरे 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 slow हो जाएगा. But हमारा intention क्या है? Force required to find the rod with constant velocity. We have to move the rod with constant velocity. मतलब external force is asking to find external force, which is almost exactly equal to this of force. So if I given this force almost same, मतलब थोड़ा ज्यादा होगा 0.01, but neglect करो दोनों सेम है. So लगा क्या होगा? धीरे 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 it will move with a constant velocity, right? So external force find करो. How to find external force? Which is nothing but this force only. Formula क्या है? IBL sin theta, right? Theta is angle between length and magnetic field. Angle is how much? Length, L and B के बीच में angle, right? Length and magnetic field. Inverse 90, right? So there is nothing but IBL. This much force देना पड़ेगा to move with a constant velocity. Now substitute here. I is how much? F is equal to BVL by R plus R times BL. So B into B, B square. So I can write like this simply. And L into L is L square, right? So B square, L square. Yeah, समझ में? IBL. I is, we substitute like this. B is B into B, B. L is L into L, L square. This is a force. इतना external force देना पड़ेगा so that the rod will move with a constant velocity. Now next find करो. Power input by the applied force and power output find करो. power input. Power का formula याद है? Instantaneous power which we studied in the 11th class. Power in terms of velocity में याद है? You know force, you know velocity, right? So force into velocity is called input power. मतलब input initially कितना power है? Okay, okay, कितना होगा? Force is this much into velocity. So कितना होगा? Multiply v into v square हो जाएगा. So b square L square by r plus r. This is the input power, mechanical power, input power, rod input power इतना आ रहा है. Okay. Now output power find करो. Output power when a current start flowing in the wire, power का formula क्या है? Conductor में I square r, right? So इसका भी r, इसका भी दोनों r है ना, दोनों I square r को add करो, that is output power. Okay, output power is how much? I square r. So I square into capital R plus I square into small r. I square times of r plus small r. So I के जगह में लगाओ. I के जगह में कितना है? This is right. So इसको square means क्या होगा? B square L square by r plus r whole square into r plus r is r plus r. This is the power output. Power output means when the rod is moving, current produce होगा. Current is flowing in a resistor. इधर भी power loss होगा ना, dissipated power I square r, and इधर भी loss होगा ना, dissipated power I square r. So दोनों add करने का that is the output power. Output में we are getting electrical power वाला, input वाला mechanical power वाला. Okay. These are the things in the motional EMF curve.